Welcome to today's class, and today we'll be looking at JUPEB Physics past questions. Let's dive right into it. The first question here says, a capacitor stores 0.24 coulombs. So we have the quantity of charge here as 0.24 coulombs. And then it says that it stores it at 10 volts. So the voltage or potential difference in this question was given as 10 volts. Question said calculate its capacitance. So we do not know the capacitance. And we know that our formula says that what Q is equals to CV. This is the same thing as say that my C is equals to Q over V, which means that the capacitance is equals to 0.24 divided by 10. And that will give me 0.024 farad. So the correct answer to this question is option A, which is 0.024 farad. Moving on to the next question, which is question number 2. It says the SI unit for magnetic flux is dash. Option A says Fluson. Option B says Weber. Option C says Tesla. Option D says Gauss. The SI unit for magnetic flux is Weber, which is option B. So that takes us to question number 3, which says an RLC circuit is used in a radio to tune into the Radio Lagos FM station, broadcasting at 93.5 Hz. So they gave us the frequency in this question as 93.5 Hz. Then it said the resistance is 15 ohms. So the resistance is 15 ohms. And the inductance is 1.6 Henry. The inductance is 1.6 Henry. Then it said calculate the capacitance used. Calculate the capacitance used. And we know that the frequency is equal to 1 over 2 pi root LC. This is the formula for calculating the frequency of an RLC circuit. So in this case, what I'm just going to do here, since they ask us to find the capacitance, I can decide to make the capacitance the subject of the formula. And if I do that, this will mean that I have, first I will multiply both sides, or cross multiply here, and that will give me that I have 2 pi f root LC is equals to 1. This is the same thing as saying root LC is equals to 1 over 2 pi f. So I'll take the square of both sides, which means that I'll have LC is equals to 1 over 2 pi f squared. And then I'll divide by C, which will mean that I'll have my L to be equals to 1 over, divide by L, which will mean that my C is equals to 1 over 2 pi f squared L. So this is the formula we use to calculate my capacitance, which means that the capacitance therefore will be equal to, so with this, I will use this to calculate my capacitance, which means that my capacitance will be equal to 1 over 2 pi times my frequency there is 93.5 all squared times the inductance in the question is 1.6. So this means that I have 2 pi times 93.5. This is 0.5. So that will give me 1 over 187 pi squared times 1.6. This means that the capacitance is equal to 1 over times 1.6 that will give me 1 over 55208.31. So if I divide 1 by this answer, it means that my C will be equals to 1.81 times 10 raised to the power minus 6 farad. So in this question, if I have this is the same thing as saying that my C is approximately equals to 1.8 times 10 raised to the power minus 6 farad, or you can simply say 1.8 microfarad, because times 10 raised to the power minus 6 is micro. So the correct answer to this question is option A, which is 1.8 microfarad. So that takes us to question number 4, which says, which of the following is true of electrical conductors? Which of the following is true of electrical conductors? Option A says they are materials in which some of the electrons are free electrons. Option B says they are materials in which none of the electrons are free electrons. Option C says they are materials in which all of the electrons are free electrons. Option D says they are material in which some of the neutrons are free electrons. So now your electrical conductors are materials in which some of the electrons are free electrons. We call them free mobile electrons, so that they can easily transfer your electrical current from one point of a conductor to the other point of the conductor. So some of the electrons are free electrons. So that makes the correct answer to be option A. So that takes us to question number 5, which says a battery of EMF 2.5 volts. So they gave us the EMF of this battery as 2.5 volts with an internal resistance of 0.5 ohms. So we have our internal resistance as 0.5 ohms. It's connected in series to a resistor of 10 ohms. What you have there is 10 ohms, not 102. So we have our external resistor that is connected as 10 ohms. Calculate the current flowing in the circuit. So we have to find the current flowing in the circuit. And we know that the EMF of a cell connected in a circuit is equals to I open brackets R plus R. So this is the same thing as saying that my I is equal to E over R plus R. So this is the same as saying that the current in the circuit is equals to 2.5 divided by 10 plus 0.5. This means that the current in the circuit is equals to 2.5 divided by 10.5. That will mean that I have the current in the circuit to be equals to 0.24 ampere. So the correct answer to this question, 0.24, which is what I actually have here, 0.238 ampere. So the correct answer to this question is option B, which says I have what, 0.238 ampere. So that takes us to question number 6, which says the carriers of charge in a gas are dash. The carriers of charge in a gas are dash. Now a gas, first of all, is a fluid, and fluid generally contains free mobile electrons, and some gases can also be expressed in terms of ions. They contain electrons and they also contain ions, both positive and negative ions, depend on the level of ionization of that particular gas. So option A says it contains only electrons, option B says it contains only ions, option C says it contains electrons and holes, and option D says it contains electrons and ions. The correct answer is electrons and ions, which is option D, as it does not contain holes. Holes are only for semiconductors. So the correct answer here is option D. So that takes us to question number 7, which says the force between two charges is 120 Newton. So I have my force between two charges as 120 Newton. It said if the distance between the charge is doubled. So originally the distance is distance, which is arrow. Now that's arrow 1. So my arrow 2, they are telling us for arrow 2 that it is double, which is what? 2r. They said the magnitude of the force will be, so this is F1, so F2 is unknown. And anytime we're talking about distance and talking about force here, what we're talking about is, since we're talking about charges, it means we're talking about what? Coulomb's law of electricity or electric field. And in Coulomb's law of electric field, we said that what? The force is inversely proportional to the square of their distance apart. And if that is what I have, this is the same thing as saying that my force is equals to K over R square, which means that my K is equals to FR square. So if that is what I have, this simply means that I have what? F1 arrow 1 squared is equals to F2 arrow 2 squared. And if I apply this value, if I impute these values into this formula, this means that I'll be having 120 times r squared is equal to F2 times 2r squared. So this will mean that I have 120 r squared is equals to F2 times 4r squared. R squared will cancel out r squared. I divide both sides by 4 divided by 4. This means that my F2 will be equals to 30 Newton. So looking at this, it means that the correct answer to this question is option B, which is what? 30 Newton. Moving on to the next question, which is question number 8. It says a 200-ton coil. So we have the number of tons to be 200 tons. 200 tons. Having an axial length. So it has an axial length of 30 millimeters, which is the same thing as saying I have 0.03 meters. And a radius of 10 millimeters. So we have a radius of 10 millimeters. And that will give me 0.01 meters. Is pivoted in a magnetic field having a flux density of 0.8 Tesla. So your magnetic flux density was given as 0.8 Tesla. It said if the coil carries a current of 0.5 ampere, so our current was given as 0.5 ampere. The question is calculate the torque acting on the coil. The torque acting on the coil is unknown. The torque acting on the coil is unknown. So we have to find the torque. And before we can find the torque, we have to first find the area. Now, looking at this question, they said it has what? This coil has axial length. And because it has axial length, automatically it means that this particular coil is going to be a rectangular solenoid. And because it is a rectangular solenoid, it means that the formula for our area will become what? Length times 2r. Because if I have a rectangle and we know that the radius is usually the half, it means that from here down to this place will become what? Diameter, which will be representing either the width or the breadth. And it means 2 of the radius will be equals to the diameter and it will be equals to the breadth or the width. So this is the formula we'll be using to calculate the area. It means that my area therefore is equals to 0.03 times 2 times 0.01. And that should give me 0.03 times 2 times 0.01. So that will give me 0.0006 meters squared. Or you can simply say 6.0 times 10 raised to power minus 4 meters squared. Now that we've gotten our area, we then find our torque using the formula that says that torque is equal to N BIA sine theta. And because we are trying to get our maximum torque at maximum, our sine theta is always equal to 1, which means that my torque will be equals to NBIA, because sine theta has become what? 1. So with this, we know that our torque will be equals to, the number of turns here is 200 times, the magnetic flux density here is 0.8 times, the current in the question is 0.5 times, the area that we calculated was 0.0006. So I'll multiply all of this together. That will give me 200 times 0.8 times 0.5 times 0.0006. So it means that my torque will be equals to 0.048. So Newton meters. So looking at this, it means that my torque in this particular question is 0.048 Newton meters, and the correct answer to this question is option C. So moving on from there, the next question is question number 9. It says the electric potential along an x-axis is given by the expression. So we have an expression that says V is equal to AX minus BX squared, where A and B are constant. At what point on the x-axis is the electric field 0? So we're trying to find the point on the x-axis where the electric field is 0. Now, the only way you can do that is to first of all differentiate this. So how do we differentiate this? We are going to tell them that our electric field is supposed to give us minus dV dx. So it means the negative of my differentiation of this is what my electric field is. So it means that my electric field, therefore, if I differentiate this, I'm going to be getting minus, this is minus here. So if I differentiate what I have here, my dV in terms of x, what I'm going to be having here will be left with A minus 2dx. So in the question, if this is what I have, it means that my electric field is equal to minus A plus 2dx. But in the question, they said we should find the point at which on the x-axis where our electric field will be equal to 0. It means we are trying to equate our electric field to 0. So if I equate my electric field here to 0, this means that I'll be saying that my electric field is equal to 0. And when you know what my electric field is, that what I have is minus A plus 2bx. So I will equate this to 0. This means that I have 2bx is equals to A. So I'll divide both sides by 2b divided by 2b. It means that my x is equals to A over 2b. So it means at a point where my x is equals to A over 2b, my electric field will be equal to 0. So my x is equals to A over 2b, and that is what option B, which says x is equals to A over 2b. So that takes us to question number 10, which says the essential part of an AC generator consists of the following, except the essential part of an AC generator consists of the following, except option A says feed magnet, option B says slip rings, option C says split rings, and option D says brushes. Now, all of these are part of an AC generator except the split rings. Now, the split rings are only present in DC generators in order to convert the current there to direct current. So, except option C, which is what? Split rings. So, that takes us to question number 11. We say, in an extrinsic semiconductor, electricity is conducted through dash. In an extrinsic semiconductor, electricity is conducted through dash. Please note that in all semiconductors, electricity are conducted in two ways, depending on the type of conductor. In an N conductor, the electricity is conducted through electrons. In a P conductor, the P-type conductor, the electricity is conducted through holes. So generally, in an extrinsic conductor, the electricity is conducted through electrons and holes. So we're looking for electrons and holes. So the correct answer to this question is option C, which says what? The electricity is conducted through electrons and holes. The next question, which says, question number 12, which says, a substance has a half-life of 5 minutes. So we have our half-life, T half, as 5 minutes. After 10 minutes, so the total time taken here was 10 minutes. We know that our n is equal to T over T half, which means that my n here is 10 over 5, which will give me 2. So I have 2 half-life here. Then it said the count rate was observed to be 500. So our n naught here is 500. Then they're asking us, what was its count rate at 0 time? What was its count rate at 0 time? So we're looking for the count rate at 0 time. Yeah. So this means that, so they gave us the count rate here as 500, and they're asking us to find the count rate at 0 time. We do not know. So our n naught is unknown. So in the question, what we have to find is what is the count rate at 0 time. But we know that our original count rate n is equals to n at 0 time times 1 over 2 raised to power n. So this is the same thing as saying that I have 500 is equal to n naught times 1 over 2 raised to power 2, which will give me 500 to be equals to n naught times 1 over 4. So this is the same thing as saying that I have 500 is equals to n over n naught over 4. So I'll cross multiply here, which means that my n naught will be equals to 500 times 4, which will give me 2000. So it means that at 0 time, the count rate was 2000. So that takes us to the next question, which is question number 13, which says, one of the features of the nuclear fission process is that dash. So option A says is that neutrons are not released. Option B says it leads to chain reaction. Option C says the sum of the masses of the reactant equals the sum of the masses of the product. Option D says its products are non-radioactive. Now, in nuclear fission is a type of nuclear reaction where the particles are constantly splitting. So when they split and they form protons and neutrons, or even smaller particles, those smaller particles in themselves split again to form what? Smaller particles, and they continue to split, thereby forming a chain reaction. But in the process, neutrons are generally released, electrons are generally released, and the masses of the reactant do not always equal the masses of the product as a result of what? Loss in masses that are what? That occurs in the process. So it means that the only thing that happens here, the only feature among these options here that is what synonymous with a nuclear fission reaction is what? It leads to a chain reaction. So the correct answer here is option B, that it leads to what? A chain reaction. So that takes us to the next question, which is, calculate the maximum kinetic energy of liberated electrons when calcium with a work function. So we have calcium with a work function that was given. So we have our work function given as 2.5 times 10 raised to power 8 minus 18 joules, illustrated by light of frequency. So they gave us the frequency as 8.6 times 10 raised to power 15 hertz. So we are asked to find the maximum kinetic energy, and we know that our K mass is what we are asked to find. But we know that K mass is equal to HF minus work function. So this means that I have to find this, solve this question using this formula. So with this, we know that our H is a constant. H is a constant. So our H is equal to 6.63 times 10 raised to power minus 34 joules. So our H is a constant, which is 6.63 times 10 raised to power minus 34. So if I impute this into my question, which says that my K mass therefore will be equal to H, which is 6.63 times 10 raised to power minus 34 times the frequency that was given in the question is 8.6 times 10 raised to power 15. This is minus my work function, which is 2.5 times 10 raised to power minus 18. So this means that I have 6.63 times 8.6. That will give me 5.7 times 10 raised to power 1 times 10 raised to power minus 34 times 10 raised to power 15. So this is minus 2.5 times 10 raised to power minus 18. So I will have 5.7 times 10 raised to power minus 34 plus 16. So that will give me 5.7 times 10 raised to power minus 18 minus 2.5 times 10 raised to power minus 18. So I'll have 5.7 minus 2.5. So at the end of the day, I'll be having 3.2 times 10 raised to power minus 18. So we are looking for an option that has to do with what? 3.2 times 10 raised to power minus 18. So think the closest here, without approximation, if we had not approximated, we would have gotten 3.3 times 10 raised to power minus 18 here. So the correct answer here is 3.3 times 10 raised to power minus 18, which is option C. So that takes us to the next question, which says that the characteristic X-ray depends on dash. The characteristic X-ray depends on dash. Now, your characteristic X-ray is a targeted X-ray. There are X-rays that are targeted. So your characteristic X-ray depends on the target. It does not depend on the electron energy. It does not depend on the tube voltage. It does not depend on the electron wavelength. It depends on the target. So the correct answer is option D, which means what? The target. So that is the next question, which is question number 16. It says a hydrogen atom is in the fourth excited state. So in the fourth excited state, our n is equals to 5 because at ground level, our n is equals to 1. So it means that our first excited state n is equals to 2. And if you follow it up, we know that the fourth excited state, our n is equals to 5. It says calculate the radius of the electron. Now, the first thing we are going to take note of is Boyle's radius. Our Boyle's radius, which is A naught, is a constant. And our Boyle's radius is 5.29 times 10 raised to power minus 11. So with this, we are going to find our radius of the electron. So our Rn here is unknown. So we are looking for R5 as in this case. So we know that our Rn is equal to n squared A naught over Z. And we know that the atomic number of hydrogen here is 1. So our Z is representing the atomic number. This means that my R5 is equal to 5 raised to power 2 times 5.29 times 10 raised to power minus 11 over 1. So this means that my R5 is equal to 25 times 5.29 times 10 raised to power minus 11. So this is the same as saying I have 25 times 5. So I have 125. 25 5.25 times 5.29. So that will give me 132. So I have 132.25 times 10 raised to power minus 11. So this is the same as saying I have 1.32 times 10 raised to power minus 9 meters. So looking at our option here, some of these are typographical errors. So the correct answer here will be option A, which is supposed to be what? 1.32 times 10 raised to power minus 9 meters. So that takes us to the next question, which is question number 17. It says, find the charge on a stationary oil drop of mass. So we have mass here as 0.5 kilograms, located at a distance of 5 millimeters. So our distance here was given as 5 millimeters, which is the same as saying I have 0.005 meters. Between two plates with potential difference, so they gave us the potential difference V as 1000 volts in an electric field. So the question is find the charge. So we do not know the charge. Q is unknown. But we know that our QE, our QE is equals to mg. So here I'm talking about what? The work done here, or I'm talking about the force here. Force in an electric field is equal to the force of this stationary object. So in order for us to find our E, which is the electric field, the strength of the electric field strength here, or the electric field, it means that my E is equals to V over D. So it means therefore that if I impute this, this means that QV over D is equals to mg. So using this formula, this means that my Q will be equal to QV will be equals to mdg. So I'll divide both sides by V divided by V. This means that my Q will be equal to mdg over V. So with this, we know that our Q therefore is equals to the mass that was given is 0.5 times the distance that was given in the question is 0.005 times our G is 9.8, is a constant. We know that G is 9.8 meter per second squared. So this is divided by the voltage that was given in the question is 1000. So this means that I have 0.5 times 0.005 times 9.8. So that will give me 0.0245 divided by 1000, and that will give me 0.0000245, which is the same as saying I have 2.45 times 10 raised to power minus 5 coulomb. So if you approximate it, it's the same as saying I have what? You can say you have 2.5 times 10 raised to power minus 5 coulomb. So we're looking for the option that has to do with 2.5 times 10 raised to power minus 5 coulomb. And the correct answer would be option C. So that is on the next question, which says, question number 18 says, an element and its isotope only differ in the number of dash. Now, isotope is the ability of an element to have different mass number but the same atomic number. So they have different mass number but they have the same atomic number, and the difference in their mass number is as a result of differences in their neutron number. So what they're asking you here is what causes the isotope of an element to be different, and what causes it is the amount of what? Neutrons. So it's the number of neutrons that what causes isotopy. So the correct answer here is what? Neutrons, which is what? Option B. Moving on to the next question. Question number 19. It says, what is the Broglie's wavelength for an electron moving with a speed of? So they gave us the velocity of the electron as 3.0 times 10 raised to power 6 meter per second. And they said we should find the what? The de Broglie's wavelength. We do not know. And we know that de Broglie's wavelength is equals to H over mv. So our m here is the mass of electron, and this is has been the uncertainty constant here. So it means our H here is a constant. So our H is a constant with a value of 6.63 times 10 raised to the power minus 34. And our m is also a constant here. (9.109 times 10 raised to the power minus 31). So if I impute my values, it means that my lambda, which is wavelength, de Broglie's wavelength, will be equals to 6.63 times 10 raised to the power minus 34 divided by 9.11 times 10 raised to the power minus 31 times the velocity, which is 3.0 times 10 raised to the power 6. So that would mean that I have 6.63 times 10 raised to the power minus 34 over, so here I will have 9.11 times 3. So I'll have 27.33 times 10 raised to the power minus 31 plus 6. So that will give me 6.63 times 10 raised to the power minus 34 over 2.73 times 10 raised to the power minus 24. So if I divide this, I'll have 6.63. So that will give me my lambda to be equal to 2.43 times 10 raised to the power minus 34 minus 24. So that will give me 2.43 times 10 raised to the power minus 10 meters. So looking at this, it means our correct answer to this question will be option B, which is 2.43 times 10 raised to the power minus 10 meters. Moving on to the next question, which is question number 20. It says, the electromagnetic radiation used in medicine is dash. Option A says hard X-ray, option B says soft X-ray, option C says cosmic ray, and option D says gamma ray. Now, your cosmic ray is not used in medicine at all. Now, your gamma ray and your hard X-ray are too penetrating to be used in medicine. They are high frequency rays, so they penetrate beyond the bones and they cannot be absorbed by the bone. But your soft X-ray penetrates soft tissues but can be absorbed by denser parts of the body like bones. Hence, you can have a photographic image of the bones on photographic plates or photographic sheets. So hence, your soft X-rays are used for imagery, radiography imaging. So they're using what? Your soft X-ray for radiography imaging. Hence, when you have a fracture, you do an X-ray, and what they're using is what? Soft X-ray for that what? Imaging. So the correct answer of this question is option B. So we've come to the end of today's class. I believe you had a wonderful time with us. Don't forget to come back to the channel for more questions and more tutorials of questions just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao, NEET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.